Hello, geometry students. Mr. Zacek back and better than ever, and we are in Unit 9. This is a really critical unit with a lot of really important things. So the title for our unit is this unit is called Transformations. And we have different types of transformations that we're going to talk about over the course of the next few lessons and really all throughout this unit. And a transformation is a function or a mapping that results in a change in position, shape, or size of a figure. So anything where we move, it's where we take it. So some basic transformations that you see here, we have a slide, okay, where we're just sliding the one image to the other. We may flip it, okay. That would be, so the slide, this is called a translation when we slide. A flip is called a reflection, and a turn is called a rotation. So those are some of the basic transformations. Now, the original figure is the pre-image, and the resulting figure is the image. So notationally, if a point is A, that would be the pre-image, and then we would do what we call A prime. The way that we say that is A prime. It's read that way. So that pre-image would be just the letter, and with the little kind of marking up here, that is what our image is going to be. So some transformations preserve. What does it mean to preserve? It means keep the same. So some transformations, translations, reflections, and rotations preserve distance and angle measure. So what it means is to preserve distance means that the distance between any 2 points of the image is the same as the distance between the corresponding points of the pre-image. In other words, the lengths of the sides have not changed. So the key phrase for us that we're thinking about here is preserve distance. And I point that out because this is one of those topics where you're going to be asked to explain a lot with words. And so preserve angles. So preserve distance, preserve angles, meaning that corresponding angles are going to match up. They haven't changed. All right. And so a transformation that preserves distance and angle measures is called a rigid motion, and this is a key definition for sure. Or it's also called an isometry. So that phrase is just going to be really key for you to be able to define that and to be able to write that out. And so we want to think 1 preserves distance, 2 preserves angles. In other words, the two things are going to be congruent. The pre-image and the image will be congruent. All right, so moving along here, a transformation maps every point of a figure onto its image and may be described with arrow notation. Prime notation is sometimes used to identify the image points. So different ways of different kinds of representations. So here we see this, all right, over here, JKQ, this is what we would call the pre-image because it's where it starts, and the result over here would be called the image. And one of the ways you can identify that is you see the direction of the arrows that are going here. So this line here has an arrow in that direction. And so we can use over here with that representation, we can use an arrow, or we could say that it maps it onto, and we also have some function notation that we'll look at a little bit later. So you want to list corresponding points of the pre-image and the image in the same order. just as for congruent or similar figures. So what we have here is, as you see, J is the first letter, J prime is the first letter, etc. So the one we're going to focus on in this lesson to start off is called a translation. It is a transformation that maps all points of a figure the same distance and the same direction. So same distance, same direction. We can think of a translation as a slide. Slide to the left, slide to the right. Everybody clap your hands. Okay, anyway. Next page. So since a translation maps all points the same distance in the same direction, what we see here is this is called the vector of translation. Okay, the vector of translation. All of these are the same and parallel. So I'm going to use a highlighter here to help you see this. So as we go from A to A prime, what do we see? B to B prime, C to C prime. Okay, all of those distances are congruent. All of them are congruent, and in addition to being congruent to each other, they're also parallel to each other. So all three of these, what we call vectors of translations, are parallel. So translations, as we said, preserve distance. That means that AB is congruent to A prime B prime, BC is congruent to B prime C prime, and AC is congruent to A prime C prime. So in the pre-image it goes exactly onto the image, and then in addition to that, we'll just use a different color here, red, for the angles. The angles are going to be congruent. So A and A prime, B and B prime, C and C prime. All of those angles are congruent. So a translation is a rigid motion. That's a key concept here, that it is a rigid motion. Remember, rigid motion, number one, preserves distance. Number two, preserves angle measure. All right, so we have some different notation that we can use to represent that. So the first one here, the first way we can represent this notationally is with just what are we doing to the x value, what are we doing to the y value. So this is going to take us to the right 4 and down 2. So what's happening? Well, that plus 4 means right 4, minus 2 is down 2. The second way we can write that is with a capital T. So that's a translation of 4, negative 2. And when it's written in this way, what is put in here is the pre-image, and this is the image. All right, that's kind of a little bit like the function notation that we see in like, you know, whatever, f of x equals 4 or something. That's, you know, kind of the idea from algebra, that this is the input here and this is the output. So input, output, that type of concept from algebra. And then the last way that we have, this is called component form. So the component form is, you know, just instead of using parentheses, you've got these kind of arrow things on the end, and the first number is going to affect your x value, and the second number is going to affect your y value. So all of those are the same thing. Each point of the pre-image moves 4 units to the right and 2 units down. And so if you look at this picture, this diagram that we have here, let's get a little highlighter. What's happening to B? It's going to right 4, down 2. Okay, A prime is going right 4, down 2, excuse me. Now another way to describe a translation is with a vector. Okay, so a vector, another vocabulary term that we have here. A vector is a quantity that has a magnitude, a length, and a direction. So an example of vectors, just when you think about this, are like wind speed. Wind is an example of a vector. It has a direction clearly, and it has a length, and that's the speed that it's going at. So a lot of like vector stuff comes into play in like for pilots. It was interesting. I took a trip to California, and the trip from Atlanta to Sacramento took 5 hours, and then from Sacramento back to Atlanta only took 4 hours. And the reason was on the way home I had the wind coming in what was at our backs, so it made the plane go quite a bit faster. All right, so as I'm reading this next thing, it says the direction is indicated by an arrow pointing from the tail. The tail is the initial point to the head, which is the terminal point. So you see what we have going on here. We've got this vector going from A to B. All right, so it has a direction and it has a distance. And if we were to look back here at our picture of a translation, what we see is a translation, there's a vector of translation like what we got going on here. There's a direction and a distance, right? It goes from C, and all of those are the same direction and the same distance. Okay, so just looking at different ways. The vector that defines the following translation is drawn. The vector may be described as 4, -9. This is called component form. All right, so component form is this piece right here. Let me just write it a couple of other ways. The other way we could write this, we could write it just simply as a translation of, so capital T, 4, -9, and we could put in, the first point, and then we'd get some points out that would be the resulting image. So if we called this like ABC, so ABC, and then A prime, B prime, C prime. A prime, B prime, C prime. So that's one way to write it. The other way you can do it is, okay, if we take the point XY, and then it's going to be X plus 4, Y minus 9. So all of those mean the same thing. All of those are telling us whether it's component form, or whether it's with the X and Y, or whether it's with the capital letter T, shows us that right 4, down 9. So when we want to put one more together, we have a composition of transformations, and that's a combination of 2 or more transformations. In a composition, you perform each transformation on the image of the preceding transformation. So what could happen here is if we took point A and we did one transformation, we would call that A prime, and then if we did a second transformation, we would call that A double prime. So in general, so later on in this unit, we'll do like a translation and then a reflection. Those things are coming. But for our purposes in this lesson, what we want to just highlight here is if you have 2 translations, there's really a way to make that one translation. So in general, if you have 2 translations, 2 slides, there's really one slide that could represent both of those. Okay, so we're going to answer some questions and just kind of highlight this vocabulary and hopefully get you ready for the assignments and help to solidify some of this understanding for you. Does a transformation appear to be a rigid motion? Okay, so for A, pre-image image, does it preserve distance and angle measure? No, okay, it does not preserve distance. So clearly, the image is larger than the pre-image, okay? But for B, if we look at these two, they look like they're exactly the same. One's just maybe flipped and over there. So I would say yes, because distance and angle measure are preserved. So just really using the language of the definition of a rigid motion, which is again is a key vocabulary term. So number 2, a blank is a transformation that slides every point of a pre-image the same distance and the same direction of the image. That's what we're calling a translation. Okay. A translation is a function that takes every point of a pre-image and moves it along a vector to its image. So which of the following properties are invariant under a translation? Well, that's a funny word. This showed up on the Regents exam a few years ago, and we hadn't introduced it before, so we said, whoa, we got to make sure we introduce that. But what would you do if you came across that word and you weren't sure? Well, it has a prefix in. What would happen if we took that off? Variant. Variant is kind of like the word variable, so it varies. But we have this prefix in, so it means does not change. So invariant means which do not change. So does the distance between those, is that invariant? Yes, it preserves distance. Are the angle measures? Yes, that is the same. Is the orientation? Orientation means if we slide this triangle, okay, which I'm doing a horrible job of drawing. If we slide, if this is ABC and A prime, B prime, C prime, orientation is the order of the letters if you go clockwise or counterclockwise. All right, that remains the same. Does the perimeter remain the same? Yes, that remains the same. Does the area? Yes, because they're a rigid motion. Nothing is changing in it. Collinearity. The points collinear on the pre-image are collinear on the image. Okay, so meaning something along segment AB is on AB prime, A prime, B prime. Yes. Parallelism. So if two things are parallel on the pre-image, would they be parallel on the image? Yes, that is going to be preserved. Perpendicularity, meaning if something is perpendicular, yes, that will stay the same. Is it a translation a direct or opposite isometry? The answer here is it is a direct isometry. The direct part refers to the orientation of the letters, meaning they remain the same. And isometry is another word for a rigid motion. Okay, so throwing a lot of vocabulary at you here in this. So if you have to, kind of pause, think about it, ask a question, write it down, come into class, feel free to please do that because we got a lot of vocabulary here. All right, so let's get into some of these examples. Given PQR with coordinates PQ and R, what are the vertices of this translation? We want to graph that, and then we're going to draw some other things. Okay, so when I'm doing this, first thing I want to do, and what I would encourage you is, I always list these points in a vertical descending order. I think it's a lot easier to work with that way. I'm going to go ahead and plot this triangle. So I've got P, Q is 3, 3. R is -1, 3. All right, so I'm going to use a straight edge, and I'm going to connect these. Here's my triangle. Okay, now whether I do this on the graph, so I'm going to draw an arrow, and I'm going to write my rule up here at the top, -2, -5. So I'm going to go left 2, down 5. And essentially what I'm going to do is I'm going to subtract 2 from the x value, and I'm going to subtract 5 from the y value, which would make it 0, -4. If I take away 2 from 3, that would be 1, -2. We're subtracting 5 from 3. And then we're going down 2, so it would be -3 and negative 2. I'll use a different color here to help illustrate the differences. So P prime is going to be 0, negative 4. Q prime is going to be 1, negative 2. So this is what? P prime, okay, Q prime, and then R prime would be negative 3, negative 2, R prime. So it wants us to graph both of these, label them. The labels have to be on there, okay? And so graph this and its image. So again, just as we're thinking about this vocabulary, what we have here is known as the pre-image, and this is going to be our image. All right, now it says draw P prime. So all we're going to do that, and I'm going to just choose a different color to help you see this. So from P to P prime is that segment. From Q to Q prime is that segment, and R prime is that segment. What relationship exists between those three segments? Okay, so for answer to B is P prime is congruent to Q prime is congruent to R prime. So they're all congruent, and P prime is parallel to Q prime, which is parallel to R prime. All right. Yeah, so there we go. And those are the vectors. So with the vector, we'd also want to put on just a little arrow to indicate the direction that we see there. Okay, so thinking about this, right, number one, what is it? Congruent. Number two, they're parallel to each other. All right, so a couple more questions here, and draw the vector that defines the translation. Okay, so what I'm looking for as I see this is over here, this is my pre-image because I've got the letter P. So to draw the vector, I want to go from P to P prime. Okay, that would be the vector of translation. So I'll just give you the little arrow there. Now it doesn't say that you have to draw all of them, but it would we could, but I'm not going to in this case. Now write the vector in component form. So what's going on here? How far over are we going and how far down are we going? 1, 2, 3, 4, 5, 6, 7, 8. We're going to the right 8, and we're going down 2. So component form is going to be 8, negative 2. Okay, and write a rule that describes the translation that maps this onto this. So if we were to write the rule, I would put capital T, and I would say 8, comma, negative 2, and then I would do PQRS, that's my pre-image, equals P prime, Q prime, R prime, S prime. Okay, so we've got component form, we've got a rule, all right, and we drew the vector of translation on there. Okay, the last one here is the diagram shows two moves of the black bishop in the chess game. So the first move, you can see he's going from here down to here in this one, and then he's going up from here to here. So write the translation rule for each move. So let's call this, so for A, let's go move 1. Move 1, the translation would be, looks like 1 to the right, 1, 2, 3, and down 1, 2, 3. Okay, so would that be 3, negative 3? And then move 2, the translation would be from here we're going to go 1, 2, up 1. Okay, so right 2, up 1. Is that right? Yeah, right 2, actually up 2 to get to that square, right 2, up 2. So 2, 2. So how could we write that as one move? Well, just add them together. 3 plus 2 is 5. Negative 3 plus 2 is negative 1. Okay, so that is the translation. All right, a lot of stuff here to cover. Now, I'm going to give you a little bonus for this one, and this is lab 51. And in the lab, you're going to be asked to construct this translation. And what we have here is, this is the vector of translation. So the way we're going to do this here, what does vectors have? What are the two things? Number one is a vector has a distance, and number two, a vector has a direction. So we have to account for that in our construction. So the first thing I'm going to do is, with my compass setting, I'm going to measure the distance of my vector by opening the compass up the full length of here. Okay. Now I'm going to come up to point A, and I'm going to swing an arc here for A. Then I'm going to come over to B, and I'm going to swing an arc that's at that same distance. Okay. And I'm going to come over to point C. I'm going to swing an arc that's at that same distance. And what I'm going to do is I'm going to label this one. I'm going to call this arc A. I'm going to call this arc B, and I'm going to call this arc C. Okay, what we've done so far is we have accounted for the distance. Okay, so I know that all of those arcs are going to be the same distance as vector AB. Now we need to do the direction piece. So here's how we do the direction. I come up here from the tip of my segment, and I measure how far it is from the tip to point A, and we swing an arc, and I come to the end of this, and I swing that same arc. Now that point right there is A prime. Okay, I come back to the beginning of my vector. I'm going to open it up now the length of B. Whoops, got to open it up a little bit more. Not quite that. There we go. Okay, and I come down here to the end, and I'm going to mark there. Now that intersection point is going to be B prime, because it gave us our direction. And then we're going to do the same thing down here with C. I come all the way back to the beginning, and I will bring my compass point down here, and that's not what I wanted to do. Hang on, I got to move this back a little bit. All right. Sorry. Can't see where my marking is. Okay, so we're going to come, that distance now is, let's see, is that C? Or am I a little bit off? Okay, there it is. So now I'm going to take that, and I'm going to bring it over to the end of this, and I'm going to swing my arc there. Okay, and now that intersection point is going to be C prime. And so we're going to go here, connect that to here, and we have constructed the image A prime, B prime, C prime. Okay, so in this lab there's 3 other ones that are just going to be practicing doing that same construction, so you can, kind of revisit this, but I wanted to make sure you had seen that before you got to the lab. The assignments that you have with it are not, you're not going to do the construction, but the lab one you will. Okay, so lot of stuff here, okay, a lot of stuff in our first lesson that we covered. And I want you to really think, one of the key things, obviously, apart from translation, is this rigid motion preserves distance and preserves angles. Okay, a lot of vocabulary. We'll keep using it in the future lessons, so hopefully we'll start digesting it a little bit more. And good luck with this, and I'll see you back here soon.